Now let us go to number 5, which says find the point on the parabola y squared that is closest to the point 0.3. So that is the question now, the last question. So the first thing that you want to realize here, this is supposed to be a black. The next thing that you want to realize here is this. When you are having a parabola, let's first draw it. We wanted to draw it. The parabola we're having here is y is equal to x squared. Of course, if you want to draw it, you draw it like this, and you draw it like that, and this is the parabola. So the question is, there is a point here. We want to find a point on this parabola that is closest to the point 0.3. So we have x, we have y. So our x is somewhere, x is 0, so we are here, and y is 3, 1, 2, 3, so we are here. So this point is 0.3. So we want to find a point here that is so close to that point. Is it a point here? Is it a point here? Is it a point here? Is it a point? So let's just pick a point here randomly, and we don't know what x is, so I'm gonna call it x here. And then once I have this x, I plug it in this function here. The y output is going to be x squared. So that is actually what we are having here. And most importantly, when you are having these problems here, some people usually say these are just mathematical problems, they are not useful anyway. So what is important is this. Sometimes you will find out that you are having a location. There is a point here, there is a point there, and there is a point there, and these points are actually kind of these areas, not just point. There is this location, there is that location, there is that location, and there is that location. And now out of these locations, you want to place either a clinic or a hospital somewhere. So, but you want this hospital to be at a point whereby it's closest to all these areas. You don't want it to end up biasing other locations to be way too far. So you want to centralize this hospital, or you want to centralize this school, or you want to centralize this particular clinic. So you will end up following some of these problems. So it's very useful to get used to these problems. And also another thing that you want to realize, let's say maybe you want to place a security company, and also you want to make it close to the clients, to your target market. You can always follow the same process that we are using here. Or you are having a certain insurance companies, and you want to make sure that you are not that far from your clients. Maybe you want to prevent your vehicles from getting certain problems because it's traveling too far in other areas, but you want to make sure that you're centralized. Another thing that is important when you're dealing with mathematics is not one of the subjects whereby you have to only focus on having a certain career somewhere there and say, hey, I want to only do this. Sometimes it's always wise to work with other people, even in the community, or someone who's having a small business, and look at the problems they are doing, and then you see how can you help them with mathematics, because that's what we usually do as mathematicians. Of course, the case is different with pure mathematicians, because most cases pure mathematicians only want to deal with mathematical structures, not applying in the community or in businesses or in any other organizations. But other maths is, you will always find something to do that is mathematical. So even though we are only focusing on these functions, we'll find out this function is actually modeling the area, the regions of an area. So these things, they usually do happen. So now we wanted to find out, is this point gonna be here, or is it gonna be there, or is it gonna be there, or is it gonna be there, for us to the point that is going to be close to that point. So in other words, we want to find the distance that is what is the distance between this point and other points on the curve, and then we wanted to minimize it so that we are getting closer to that particular point. So what is the distance between this point and any other point in this curve? Let me just use this point that I've highlighted there. You know the distance formula. A distance formula is saying that you must have the square root of x2 minus x1, and then you square it up, plus y2 minus y1, and then you square it up. So that is the distance formula or distance equation. And then if you look into this distance as a function of x, this is what you are going to notice here. If you want to notice something here, we're still going to have a square root, and this one I'm going to call this is x1, this is y1, this is going to be x2, this is going to be y2. So if I'm taking x2 here, we'll have x minus x1 is 0, and then I square it up, plus, and then inside here y2 is going to be an x squared minus, and then y1 is going to be a 3, and then I'm going to square it up. While we still here, I have a square, I have a square. What does that mean? It means that x is an element of real numbers. In other words, for this particular function, x, this square root is always going to be defined everywhere, because a square is always going to be positive, a square is always going to be positive. So that is what this thing means. It means that this one is defined everywhere. There are no restrictions or constraint that x can be bigger than 0 or anything. X is defined everywhere. And then let us simplify. So this is our function, which is defined everywhere. And then of course here, x minus 0 is x, and then you square it up, so we'll end up having an x squared. And then inside here we'll have x squared minus 3. So I have x squared minus 3, and then also I have x squared minus a 3. X squared times x squared, we know that we're actually going to end up having x to the power 4, and then I have x squared times minus 3, I will end up having a minus 3x squared, and then I will have minus 3 times x squared, I will have minus 3x squared, so I will have minus 6x squared. And then the next thing that we want to realize now, we'll end up having minus 3 times minus 3, which is just a positive 9, and then here you will end up having dx equal to then we have a square root here, which is going to be x squared minus 6x squared is going to be 5x squared, which is negative, and here we'll have x to the power 4 minus that, and then plus a 9. And then another thing, now we're having this dx is equal to x to the power 4 minus 5x squared plus a 9, and then I can say it is 1 over 2. And then the next thing, because I don't even have restrictions here, the next thing that I want to do here is I want to find the first derivative of this with respect to x and set it equal to 0. If this was x raised to 1 over 2, we're just going to bring the 1 over 2 and then have our x here, and then we subtract a 1 here, we'll have 1 over 2 minus 1, right? And of course 1 over 2 minus 1 is going to be minus 1 over 2. And then of course at the end of the day we're having this minus, but what is basically happening here, we are actually not having an x here, we are having x to the power 4 minus 5x squared plus a 9. So that is actually what we're having. So we end up having this 1 over 2. Because this is not only x is a function on its own, we have to multiply by its derivative according to the chain rule. That is what is important here and what you need to remember. The next thing that you need to realize here, because of that negative here, it means that we are having 1 over 2 times x to the power 4, not 5, x to the power 4 minus 5x squared plus a 9, all raised to 1 over 2, but now it's positive because negative, it means it's in the denominator. But if I don't want to place it in the denominator, the fraction there, I just have to use this one here. It's just the substitute of 1 over 2. The square root is the same as 1 over 2. times. What is this derivative? The derivative of this is going to be 4x to the power 3 minus 5. I bring the 4 down, I subtract a 1, I have a 3. Here I bring the 2 down, I will end up having a 10x. And then this one will go away. So we'll end up having this and a 10x. That is what is important here. And then once you are having this nice thing here, what you will end up having is very close to 4x to the power 3 minus 10x all over 2 times the square root of x to the power 4 minus 5x squared plus a 9. And then we are having our d prime of x here. And of course, if you look at 4x cubed minus 10x, you will see that 2x is common here. So you will end up having your 2x being common. And then inside, when I'm taking 2x here, I will end up getting 2x squared remaining minus 5. So take a look into this. 2 times 2x squared is going to be 4x cubed, which is that. And then 2 times 2x times 5 is going to be 10x. So we're good to go. I have a 2 in the numerator and I have a 2 in the denominator. So this 2 here cancels out with this 2 here. So that is actually now the first derivative. The next step, you want to make the first derivative equal to 0. So you want your d prime of x equal to 0. So when is this thing gonna be equal to 0? Is when the numerator, which is x to x squared minus 5, is equal to 0. Because if the denominator is equal to 0, this is going to be undefined. So this can only be 0 if the numerator is equal to 0. In other words, when x is equal to 0, or when 2x squared minus a 5 is equal to 0. So we're having an x equal to 0, or we are having a 2x squared is equal to a 5, or we are having an x squared equal to 5 over 2. And of course here you can either end up having an x equal to plus or minus the square root of 5 over a 2. So we're having critical numbers here, which is x is equal to 0, or let me just do this, or x is equal to minus square root of 5 over a 2, or x is equal to just the square root of 5 over a 2. So we're having these 3 critical numbers. And then the second thing that we want to end up finding here is find the values of x making d prime of x undefined. So for this one here to be undefined, it's going to be undefined if the denominator is equal to a 0. So in other words, we are looking for the square root of square root of x to the power 4 x to the power 4 minus 5x squared plus a 9 equal to 0. We're looking for this, but d prime of x is let me do this instead. But x to the power 4 minus 5x squared plus a 9 is greater than 0 for all x. Why am I saying that? Is because here we said that this thing here is defined everywhere. This square root is defined everywhere because this is positive, that is positive. And of course, this was the same as that, and this was the same as that, this is the same as that. And I'm still talking about the same thing here. So this one is always positive for all values of x. So d prime of x is always defined. So it is always defined. So we don't have any critical numbers that are found by making this undefined. We only have those three. The next thing that we need to find now, what is the distance when x is equal to 0, which is this one here. And the second thing is what is the distance when x is equal to minus the square root of 5 over 2. And then the third thing is we want to find the distance when x is equal to the square root of 5 over 2. That's what we actually end up looking for. And then when x is equal to 0, we go to the function there. So we will find out that in this function here, once I plug in, where's the function? This one here. I will get 0. I have that. So this is actually the function. Let me write it here. So I will end up, remember that our d of x is equal to the square root of x to the power 4 minus 5x squared plus a 9. So here I will end up having the square root of 0 to the power 4 minus 5 times 0 squared plus a 9. And this thing is going to be the square root of 0 minus 0, the square root of 9. And the square root of 9, we know that it is just equal to, this is positive, so the square root of a positive number is always going to be positive, so this is just a 3. And then we come here, here we are having the square root of, we have minus 5 over, that's not what I'm doing here. We're supposed to end up having minus the square root of 5 over a 2, and then we raise it to a 4. And then after that, we say minus 5 times minus the square root of 5 over a 2, and then you square it up, and then you add a 9. Then you will have a final answer. The same thing here. You can work these things out, but for the sake of time, I'm just going to plug in here. So this one here is just going to be the square root of 5 over 2 raised to 4 minus 5, and then here you will end up just having the square root of 5 over 2 squared plus a 9. One thing for sure is that this minus here, because we are having an even number here, it's going to go away, and this minus here, because we are having an even number, that's going to go away. So the answer you're supposed to get here is the same as the answer you're supposed to get here because of these two numbers. But let's work it out. I have a square root. I have the negative square root of 5 over a 2. And then of course I want to raise this to the power 4, and then from there I want to subtract. I have a 5, and then inside I have a negative, I have a square root, I have a 5 over a 2, and then of course this I am going to square it up, and then I have a plus 9 there. The answer that I'm getting here is 11 over a 2. Is that possible? Let me look into it. Is that even possible? So we are having, let me just assume it is possible, 11 over a 2, which is approximately, let me do that. It is approximately 1.66. So that is the distance. And then the second one here is supposed to be the same. Like I said, it's not going to change that much. Because that 4 is going to take the negative out because it's a square. I think the answer is still going to be the same. This one is also going to be the square root of 11 over 2, which is approximately 1.66. So I am having these two. What was the question saying? The question here was saying that find the points on the parabola that is closest. So we want to minimize the distance. So if you look here, when we are having 0, 0 is 3, the distance is 3, but here the distance is closer. So you can say that the absolute max, no, it's absolute mean. The absolute minimum distance is equal to 1.66 1.66, and then units, and then at, so the first point here we are actually having minus square root x is this x over 2, and then what is the y value, and then the second one at 5 over 2, and then we have a y value. How do we find a y value on the curve? We know that on the curve, this is actually the curve. On the curve, y is equal to x squared, so we are looking for the y value. So this one here, we're just having this, we have negative square root 5 over 2, and then that is going to be our y, but you have to square it up. When you're squaring this up, this is going to be the same as minus square root 5 over 2 times minus square root 5 over 2, and a negative and a negative will give you a positive. A square root and a square root, they will end up cancelling out because you're squaring it up, and then you will end up having 5 over 2, and of course here you will end up having 5 over 2. So at this point and at that point on the curve, we are actually having the closest points that are so close to the point 0.3. So these are the points that we're actually looking for here. You can see that the procedure is still the same. Hopefully you understood that we first have to formulate. Once we formulate, we take the first derivative, we find the turning points, and then if we are having a domain that starts somewhere and ends somewhere at finite values, that's when we started to also check the outputs of those values. But if we are not having any of those, we only focus on the turning points only, which is when the first derivative equal to 0 or when it is undefined, those 2 points. So for part A, we end here. So we want to end up starting at part B now. We want to look at part B, and of course you know what we are doing with part B.